Have you ever stopped to wonder if there are colors out there that our eyes just can't see? Well, today, we're going to explore how humanity learned to see the universe in a completely new light. And I mean that literally. We're diving into the incredible world of radio telescopes and the vast, invisible cosmos they reveal to us.
So let's start with this idea. Imagine you're standing in front of a stunning masterpiece painting, but you're wearing these special glasses that only let you see the color green. You'd see the leaves on the tree, sure, maybe some grass in a field, but you would miss everything else. The blue sky, the red flowers, a yellow sun. For pretty much all of human history, that's exactly how we've been looking at the universe.
You see, our eyes are only tuned to a tiny, tiny little slice of reality. We're not just missing a few shades here and there, we're missing almost the entire painting. So that begs the really important question. What else is out there? What cosmic colors have we been completely blind to? To answer that, we've got to start with a really fundamental concept. And you know, it might just surprise you.
Okay, first things first, we have to get a huge misconception out of the way. When we say the word radio, our brains immediately jump to sound, right? We think music, talk shows, that static between stations. But in physics, in astronomy, radio has absolutely nothing to do with sound.
So if radio waves aren't sound, then what are they? Well, here's the absolute truth. They're light. That's it. They're made of the exact same particles, photons, that are streaming from the lamp on your desk right now. It is all just light.
So if it's all light, then what's the difference? Well, as you can see right here, it all boils down to one thing: wavelength. The light our eyes can see has incredibly tiny waves, measured in nanometers. That's billionths of a meter. But radio waves, they are gigantic. They can range from the size of a baseball all the way up to the size of a mountain. It's all just one big continuous rainbow. Our eyes just happen to give up after the color red.
Okay, so if a radio telescope is really just a camera for a different kind of light, why doesn't it look like a regular telescope? You know, why do we need these enormous dishes?
Well, it's all about a principle called resolution. To get a nice, sharp image, your light collector, whether that's a lens or a mirror, has to be a lot bigger than the wave you're trying to catch. So for those tiny visible light waves, our eyeballs work just fine. But to see a wave that's the size of a house, well, you're going to need a collector that's even bigger than that.
And get this, here's a wild thought for you. If our biology had evolved to see the radio waves that are all around us, our eyeballs wouldn't fit in our heads. No way. They'd need to be the size of huge satellite dishes.
So if these telescopes are collecting these giant invisible waves, how in the world do we get those absolutely breathtaking, colorful pictures of space we've all seen? This is probably the #1 question people have about this. It seems kind of like magic, but it's actually just a brilliant process of translation.
The best way to think about it is like a cosmic paint by numbers. So step 1, the telescope scans a patch of sky, but it's not taking a picture. It's measuring the strength or intensity of the radio signal at every single point. Then step 2, all that data gets turned into a giant grid of numbers, basically a spreadsheet for the cosmos. And now for the really cool, creative part. Scientists assign a visible color to those numbers. They might say, okay, the weakest signals, let's make them blue. The strongest, most intense signals, let's make those bright red.
So it's really important to remember this. When you see one of these incredible images, you're not actually seeing a photograph of what's out there. You're looking at a data visualization, a beautiful, colorful map of invisible energy that's been translated so our brains can finally understand it.
So why go through all this trouble? What is the payoff for building these massive instruments just to see things that are invisible? I mean, what secrets does this hidden part of the universe actually hold?
This slide really gets to the heart of it. Our traditional optical telescopes, they're amazing at seeing hot, glowing things, like stars. They see the fires of the cosmos. But radio telescopes, they're masters at seeing things that are actually very cold, or things that are driven by incredibly powerful magnetic forces. They let us see the rest of the story.
And it's in that cold, non-glowing universe where the biggest secrets are hiding. When we turn on our radio vision, the darkness between the stars suddenly lights up. We can see these colossal, freezing clouds of hydrogen gas, the very nurseries for new stars. We see the impossibly powerful jets of energy being blasted out from supermassive black holes. We can even see the oldest light in existence, that faint, leftover glow from the Big Bang itself. It's just incredible. You know, all of this fundamentally changes our place in the universe. It's about way more than just new, pretty pictures.
It's about expanding the very definition of what it means to see.
And that really brings us to a pretty profound realization. The whole idea of color, red, green, blue, that's a human thing. It's a beautiful product of our own specific biology. But light, in all of its magnificent forms, all its wavelengths, that is a fundamental truth of the cosmos. And radio astronomy is our way of seeing past the limits of our own evolution.
So by building these incredible instruments, we've done something truly amazing. We've admitted that our senses only tell us a tiny fraction of the story. We've stopped peering at the vastness of the cosmos through the tiny keyhole of our own biology. And we have finally thrown the door wide open. And you just have to wonder, what other invisible wonders are out there, just waiting for us to find a new way to